Well, good day, viewers. Today we have a Subaru here with an intermittent crank no start condition. Now, it's been sitting for about 4 or 5 days here, and it's been minus 20 Celsius. It's nice and sunny today. Let's see if it'll start today. Check engine light is on. Why did the cooling fan run? Why is the cooling fan running? Well, it started. Why is the check engine light flashing? It's not misfiring. That's strange. Well, it is running, so we're going to bring it in the shop and put a scanner on it. That's definitely strange. 261,000 kilometers on this thing. It's not misfiring. Why is the check engine light blinking? Now let's bring it in the shop. So as far as I know, this is a new vehicle record. 2010 Forester X. Sixth VIN character. Sixth VIN character is a 6. Well, why doesn't it pick that? Oh, because they're both 6s. I'll put the odometer reading in after. Let's do a code scan. I believe I can do that with it running. See what computers have to offer for codes. Oxygen sensor range performance. Well, that shouldn't make the check engine light blink. Oxygen sensor heater control circuit low. Bank 1 sensor 1, bank 1 sensor 1, bank 1 sensor 1. I'll pick up when we get to the end of this scan. So we're at the end of the scan. Got 3 codes related to the bank 1 sensor 1 oxygen sensor. In the ABS, we got a steering angle power supply malfunction and history, and vehicle dynamics control interruption because of engine instructions. Well, because of the engine codes, the ABS and stability control will be disabled. And then we got an any of 4 ABS signal fault. Can't you tell which one? Power supply for body integration unit. OBD2 side of things, we actually have a P0420 catalyst efficiency below threshold. That's interesting. That's in OBD2 side of the computer, but not the manufacturer's side of the computer. So I'm going to go into the ECM and look at data and see if it is actually commanding that check engine light on and off. It is still flashing because I haven't shut it off since I drove it in the shop. Engine data. I thought when I turned the key on, I heard the cooling fan cycle on, off, almost at the same frequency of the check engine light. Rad fan relay is not running now. We look for the check engine light here. Okay, here we go. Okay, so here's the malfunction indicator light. It says it's off. Let's have a look in the dash to see if it is in fact still off. Liar. That is strange. Well, let's shut it off and restart it and see if it stops doing that. Just turn the key on and see what happens with the key on. There goes the cooling fan running. And I hear a relay clicking under the dash down here. Well, that is definitely weird. Let's have a look at the data in the instrument cluster. I'm pretty sure that check engine light is hardwired. So I don't see the selection for the instrument cluster here other than the body integration unit, which is like a BCM. I don't think that's the instrument cluster. Surely this thing's got a smart instrument cluster or a networked instrument cluster. Let's look at data in here and see if we see anything related to the dash indicator lights. This is body stuff. Power windows, power door locks. Sport blink. Small light switch. That's interesting. What is a small light switch? Arc switch, rear wiper, key lock, sport lamp. Okay, I'm going to do a little digging, a little research here and see if there's anything common to cause this problem. So I've got the battery charger on it, set at 13.6 volts. And you can hear the radiator cooling fan cycling on and the AC compressor engaging. Sure, the AC compressor is controlled by the ECM, so why would it be doing that? And that's at the same frequency as the check engine light. Now the interesting thing is the check engine light is not flashing now. It's on steady. I'm going to try and clear the codes. It's almost like it's in an actuation test mode. You can hear a relay clicking under the dash. That is strange. I'm going to try clearing the codes. So I'm looking at engine data here, and the air conditioning compressor signal is going on and off. Radiator fan relay number 2 is also being switched on and off. That is not normal. But the ECM is commanding it. Let's just try clearing the codes out of the ECM. Clear generic codes? I've never seen the option to clear generic codes only. After clearing codes, you're supposed to be cycled off and on, or codes will not clear. Okay. Let's clear manufacturer specific codes. I'm going to cycle the key. Cycle the key and it's still doing it. Let's read the codes and see if it cleared them. D-check diagnosis in progress to disconnect the test mode connector. Oh really? That's what I said. It sounds like it's in some kind of test mode. I wonder. Okay, I'm going to do a little research and find out what this D-check is. I took a look underneath the fuse panel under the hood to see if there was a self-test port. This has got to be something Subaru specific. So give me a few minutes. So here's a case on Identifix. Check engine light flashing, check codes had at one time. If the MIL is flashing in a slow on-off pattern, the fans and other items cycle on and off, key on, engine off. Find and disconnect the test mode connectors. Look under the glove box at the upper edge of the carpet for 2 green connectors connected together. Blue wire in one, black blue wire in the other, and unplug the connectors. Well, let's see if we can find that. So under the passenger side of the dash, let's set this up so we can see what we're doing here. There is a connector. It was tucked up above the carpet there. Yeah, hang on. So this connector has got to be the test connector, and it's plugged together, and I gather it's not supposed to be. Let's unplug it. So I got the connector unplugged, but I'll cycle the key. Well, isn't that special? So I gather that's a self-test connector for some Subaru specific test, and it's not supposed to be connected. Let's see if that eliminates the flashing MIL. So I'm going to start it up. Check engine light is on solid now, and we likely have an O2 sensor heater code or something. Let's see if we can clear the codes, but that self-test connector is likely not supposed to be plugged together. So looking at these cases here, somebody's done work in the dash, like a radio or cabin filter or something, and then inadvertently plugged those 2 connectors together thinking they had disconnected them. Wires at carpet edge were missing the green plastic connectors and were stripped at the ends and finally touched together. Well, that's not the case. This one was plugged together. Disconnect test connector. So let's go back into the engine controls. And see what codes it's got now. Why is it asking me this again? I had inadvertently closed the file on it. I guess that's asking me why. Let's go into the engine control computer. It's possible it won't clear the codes correctly in that test mode. I've never seen that before, but I'm not a licensed Subaru tech. Let's see. Bank 1, sensor 1, and control module performance. That's on the OBD2 side, on the manufacturer side. Throttle system range performance. That's interesting. That wasn't there before. Well, let's clear these out. Who knows what kind of hocus pocus it could do with that. Okay, I gotta turn the key off. Key on, engine off. So I'm clearing the codes with the key on, engine off. It does say you need to cycle the key. I'm gonna clear the codes on the generic side too. Now I'll cycle the key off. Cycle the key off and back on. Let's look at codes on the manufacturer side of things. No codes. Let's look at codes on the generic side. No codes. Let's see if there's any pending codes. No codes. Let's start it up and see if the check engine light comes back on. It's possible that that O2 sensor heater code won't set until it's running. So the check engine light returned again, so there's obviously a problem with with the oxygen sensor. Let's see what codes it set. Bank 1 sensor 1, O2 sensor heater code, heater control circuit. Well, we'll put it up in the air and have a quick look at that and see if there's anything obviously wrong. Check the heater circuit. So we got this up in the air and I notice a drip. And it looks like it's coming from the oil filter. But then again, it could be coming from the head gasket. It's been leaking quite a while. You can see the oil residue here. It's free undercoating. Well, not necessarily free, you gotta put oil in the engine. But that oxygen sensor is, bank 1 sensor 1 is on the right side. Now you notice there's a ground wire corroded off there. This one's still intact, amazingly. So that's good. Usually both these ground wires are corroded off. So we'll fix this one ground wire with a new ground wire. And we'll test the O2 sensor heater circuit. Yeah, I wonder if that connector goes up top. You can see the other end of that ground wire. And check the oil level. So if you take the air induction inlet off, you can disconnect the oxygen sensor connector. Bank 1 sensor 1 is the first oxygen sensor in the exhaust flow, so this one here. If you look at this connector here, you'll see there are 4 wires to it. 2 of them are gold plated. The gold plated pins, I would assume, are the oxygen sensor themselves. The other 2 pins are for the heater. So we're going to just quickly measure continuity across this heater circuit with a couple of test probes. Got the ohmmeter set up here. And it shows 7 ohms of resistance. So it's not open. Now I don't know if that's correct or not, but fortunately we have another oxygen sensor right beside it. Mind you, this one is maybe an AFR. No, it's not. No, it's not. That one's the bank 1 sensor 2. Let's see if I can unplug that one. Or better yet, put a test light across the 2 pins on here that the O2 sensor heater would actually activate and see if it lights a test light. And I'm going to see if I got a noise light that'll fit in there. So you can see that the heater circuit is pulsing. I've got the 194 bulb connected across there. I'm curious if the code will go to history now. According to the information in the Advantage Pro here, resistance should be less than 30 ohms. So I tried to check it compared to the other sensor, which is, I believe, is the bank 1 sensor 2 sensor. I'm going to have to look at that exhaust plate. That one's open. 5 arrows pointing up indicates over scale, over limits. Now I disconnected the test light off that, what I thought was bank 1 sensor 1. I wonder if it set a different heater code. Okay, let's see what codes it's got now. Should theoretically have 2 codes for heater circuits. Bank 1 sensor 2 and bank 1 sensor 1. So which one's which now? Let's get this straight. Okay, so I'm a dummy. So this is the exhaust coming out and goes this way. So bank 1 sensor 1 is the one right there, not the other one over here. That's sensor 2, and that one I tested first, tested fine. So this is actually referred to as the air-fuel ratio sensor. So it needs one of those. Now that's not going to cause a starting problem. And on 2 occasions now, after clearing the codes, it cranked longer than I would have liked before it actually fired. So I'm wondering if it has an intermittent crank sensor problem. So it pays to read instructions. It says, note, initial diagnosis of electronic throttle control is performed after memory clearance. For this reason, wait 10 seconds or more after turning the ignition switch to on before starting the engine. I wasn't doing that. I was turning it off and trying to start it, and it would crank and crank and crank and crank. So let's do it the proper way. I've got a test light connected across the actual HO2S, or air fuel ratio sensor heater circuit now. So I'm going to turn the key off. And back on. This time I'm going to wait 10 seconds. At least to do initial diagnosis of the throttle body. Let's see if the codes are cleared. So it likes that light in there. Mind you, I haven't started it yet. So let's start it now and see what happens. Well, the light came back on immediately, and my light is not blinking. Let's see what it's got for current codes. It may not like the resistance of that light bulb. I know the sensor is definitely open, so it needs a sensor, but there could be problems with the wiring. Either that or my probe isn't making a contact in there. The car started fine, obviously. So obviously the extended crank time after the code clear is normal if you don't wait 10 seconds after cycling the key off. Gonna look at engine data, specifically engine RPM and injector pulse if it has it. Engine speed, fuel injection pulse width in milliseconds. Let's cycle the key and run it. Seems to be starting perfectly fine now. So I'm going to check the oil level and the oil quality, maybe do an oil change on this thing, see if that oil filter is leaking, and discuss replacement of the air fuel ratio sensor with the customer. So we're having a look underneath here, and you can see up beside the oil filter there's a drop of oil from the head gasket surface, and I think it could be leaking there. I think that's a known condition. So we don't want to spend too much money on this thing because it's got high mileage and obviously oil leaks. That O2 sensor won't cause a startability problem in my opinion, so we're going to hold off changing it. It's actually an air fuel ratio sensor and it's almost 400 bucks. I am changing the oil because it's down 1.5 liters and it's very dirty, but you can see the oil's been dripping here. I'm going to clean that off after I put oil in it and run it and see if it drips from the head gasket surface. So we got fresh oil in it. It's not leaking profusely, but if you look at this side, it's also wet in the same general area between the head gasket and the block, or the head and the block. And I understand these are prone to leaking in that area, so
And if the oil filter leaked, it wouldn't run uphill, in my opinion. I have to go up a half an inch to get to that spot where it was clinging onto the head gasket surface. So, given this thing is a little long in the tooth and it's potentially got a catalyst efficiency code anyways, because that was in history, putting an air-fuel ratio sensor in it is not going to make it run any better than it is right now, and then all it's going to do is enable the catalyst efficiency monitor, and after 2 drive cycles it'll turn the MIL on for that instead. So that'll disable the cruise control and the AC, well I'm not the AC, but cruise control. And I'm not sure if being in that test mode affects startability or not. It seemed to start okay. It had been sitting for 5 days outside in -20 weather. But we're going to park it outside and let's see how it runs, or starts tomorrow. So with the check engine light on and the cruise light blinking, the cruise control is not going to work. That's a Subaru function. Whenever there's a significant engine emission related code, they kill the cruise control and the traction control, and likely the ABS too, but it doesn't specify that. Now there was a warning light over here on the right side. There is back on for the headlights. Changed the right low beam bulb. Now it's working, so I'm not sure why the headlights are working fine. I'm not sure what this symbol in the bottom right here is. I'll have to look it up. The other issue that I see is this thing's had a timing belt done back in 2018, and the sticker is illegible. I can't read the mileage when it was done, but it's got 260,000 on it now, kilometers. So it's due for another timing belt. So it's got to do some serious soul searching on this car if it's worth investing any significant money in it, or just drive it until it dies. The exhaust is ready to fail. It's been patched up numerous times. The mufflers are both leaking, rusted through. So gotta have a heart-to-heart with the customer. So just following up, that indicator light on the bottom right is for the automatic headlamp leveling system on models with HID lights, which has for the low beam. It was the high beam bulb that was burnt out in 9005. I put one in. I assumed that was a headlight out warning message, but nevertheless there's a problem with the headlight leveling system. I'm going to take it to the Subaru dealer, it says. There's no codes being generated in any of the controllers that I have access to with the snap-on scan tool, so that's a minor issue. Just curious, that's all. Thanks. So I searched through Identifix to see what that D-check mode was for, and I could find nothing mentioned in the service literature about it. So I did a Google search and I found this Subaru blog where somebody's talking about it. It's a diagnostic mode that is used to test all the basic functionality of the ECU controls like fuel pump and radiator fans. Well, we know it runs the fan and the AC compressor with the key on, engine off. Simplest way to tell if it's in test mode is the 2 green connectors are plugged together. So if the test mode is active, you can hear the radiator fan cycle, the fuel pump cycle. There will be a flashing check engine light. So that's not supposed to be connected. So it doesn't say, why would I put it into test mode? The most common reason a Subaru would be put into test mode is reflash the ECU in a non-CAN bus car. I would think this is a CAN bus car because it's 2010. Usually CAN bus took effect by 2007. You can think of the test mode plugs as flashing plugs that get connected when uploading and downloading information to the ECU, usually with a COB access port. Standalone ECUs like Haltech do not have test mode. So CAN bus card plugging in the test mode connectors is not needed for re-flashing the ECU. So just a little bit of information, that connector is not supposed to be plugged in. I can't find out what it actually does. Maybe some Subaru tech can pipe in here and enlighten us all. Just a little follow-up. Thanks for watching.